So what if I want to graph a piecewise defined function? In general, the thing to know is that the intervals in the right-hand side there, which tell you the cases, they're also going to correspond to sections of the horizontal or x-axis, and those will correspond to vertical strips, or I like to call them zones, where you will draw the various graphs. Each graph that you draw has to stay in its own zone. This is crucial. So let's start with this example of a two-piece graph where you do one thing for non-negative numbers and a different thing for negative numbers. We're going to get ourselves a nice set of axes, and we're going to mark the zones where we draw the various graphs. A hack for this is you draw a vertical line for every number that you see over here. And so the idea here is that when x is greater than or equal to 0, which corresponds to this part of the x-axis, which corresponds to this side of the plane, we're going to be drawing a parabola. And when x is less than 0, that corresponds to this section of the x-axis, which corresponds to this area of the plane. We're going to be drawing a diagonal line instead. So you mark out your various zones, and then you draw the different graph shapes. We have a parabola and we have a line. I was careful to go right up to the dotted line, but not to go over. So it is true that this, y equals x squared minus 2, that is a parabola that is shifted down 2 units. But because we're working with piecewise functions, I'm only going to draw half of that shape. And it's the same with this diagonal line. I'm only going to draw half of this diagonal line. And once I'm done with that, there's one step remaining, which is I need to fill in open circles and dots at the ends of these graphs. I need to indicate whether the points 0, 1 and 0, -2 are in my graph. An open circle will always mean this point should not count in the graph, and a closed dot will always mean this point does count as being in the graph. Usually, it's a good pattern, a good trick to remember, that whenever you see a strict inequality symbol, that will correspond to a bubble, and whenever you see greater than or equal to or less than or equal to, that's going to correspond to a closed dot. Not every time, but most of the time. And tying this back to basic function theory, if we were to plug 0 into this function, we're supposed to be looking at this pile of numbers, that's where 0 falls, and suppose we're supposed to be using this recipe right here. And so f of 0 is literally equal to -2. It makes sense that there should be a dot here when we look at x equals 0, and no dot here, because we want to indicate that f of 0 is equal to -2 and nothing else.